Hello everyone, and welcome to the Cosmic Classroom. Today we'd like to give a special welcome to students and teachers at Kirkman Park Elementary School, right next door to us here at High Point University. Today's video is made especially for you all. A few weeks ago we were able to take pictures of your school, and using our special planetarium software, we were able to take a look at the night sky right above your school building. And if we look right over the top, we were able to see some popular constellations, like one of the zodiac constellations, Aries, and a very recognizable figure, Orion the Hunter. Up in our night sky, there are also a lot of things that our eyes do not pick up on. Just looking up at the night sky without help from telescopes, we are not able to see a lot of these fainter stars in the sky. One reason this can happen is due to your surroundings. If there is too much light pollution nearby, we cannot see too many stars in the sky. Another reason this can happen, even if you are in an empty field, is because some stars are too far away for us to see with just our own eyes. There are also other things we are unable to see, like radio waves and gamma rays. These things our eyes cannot see because they are not physical objects like a planet or a star, but rather they are light that exists outside of the visible spectrum. Visible light is just a very small part of the larger electromagnetic spectrum, which is the entire range of light that exists, including light that our eyes cannot see, like these radio waves and gamma rays. The visible spectrum of light contains all of the colors that we know: red, orange, yellow, green, blue, indigo, and violet, and all of the combinations of these colors, which includes black and white. What makes this light visible is that it is just right for our eyes to be able to take it in. If light is even a little bit longer or shorter than this very specific range, we are not able to see it with just our eyes. So there are a lot of things hidden in the night sky in our universe. We need help from tools to help us see. One tool we can use is a filter. So let's take a look at a few different surveys of the sky that use different filters to see what is usually invisible, and to see what these things can tell us about our galaxy and our universe. The first survey we'll look at is a near-infrared. So that falls on the longer side outside of our visible spectrum. And so what this does is help us see more objects in our galaxy by making the clouds of cosmic dust transparent. We don't usually see this dust in our sky. It doesn't look like clouds in the night sky that we can sometimes see. But with the help of this survey, we are able to see more objects and stars in our sky. And so this lets us see all the way to the center of our galaxy, this very bright section in the sky that's almost like a line. Seeing this very bright band in the sky lets us know that we are looking inwards towards the center of our galaxy, and that we live in the outer part. Now let's take a look at the sky through a far infrared light. This survey highlights all of the dust in our galaxy instead of getting rid of it. While this may seem like it's making it harder to see stars in our sky and to tell us something, this cosmic dust is actually very useful because it is made up of elements like carbon, oxygen, and iron, which are very important to a lot of astronomical processes, like the formation of stars and planetary systems. And so where it is brighter is where it is denser and there's more dust gathered together. And this again creates a line in the sky towards the center of our galaxy. Next, let's look farther into our galaxy and back to the oldest light in the universe. The PLANCK mission with the European Space Agency looked at the sky to see changes in the cosmic microwave background, radiation that was imprinted on the sky when the universe was just 370,000 years old. This map shows temperature changes in areas that have different densities, where there's different amounts of matter, which has helped scientists learn more about the very beginnings of stars and galaxies that we see today. Lastly, we'll look at the Planck mass distribution. This shows us how matter is spread out between us here on Earth and the edge of the observable universe. The areas that are darker are areas where there is more mass, and so the lighter areas have less mass. And these grayed out parts are where our own galaxy was too bright to let us map some of the more distant areas. This, along with other information, tells scientists that things are organized in the universe with empty space around those areas that have a lot more matter and mass. These grayed out areas are also along the center part of our galaxy that we are able to see with the first survey and the bright band that we saw with the second survey. And so these three things confirm our outer position in our own galaxy, and that there are a lot of important elements towards the center, and so there are a lot of stars and planets there. And so with the help of all of these surveys, we now know a little bit more about our invisible universe around us and our own galaxy. Thanks for watching, and don't forget, keep looking up.